Hello, everyone. Welcome to the seventh session of Smart City Water's webinar. Today, we are going to talk about dual drainage modeling. And since dual drainage modeling is a, a total different world, and there are a lot that we can talk about, um, I am going to divide it into two parts. In one part, we are going to uh, solely focus on uh, the theories of dual drainage modeling, and I'm going to present what dual drainage modeling is. And then later on, I'm going to open VO SWMM and get a hands on the software and see how we actually can model a subcatchment doing dual drainage modeling. All right. So before I start, I would like to ask you guys to make sure that you have us followed on Twitter as well as our LinkedIn page, because we post about our next webinars and we post about our promotion and if we have any new kind of material for water resource community. And also on top of that, I want to let you guys know that this session is being recorded and we post this webinars, like all of this, the last 6 sessions of them on our YouTube channel. So if you just Google us or if you search us as Smart City Water Incorporation or Smart City Water INC dot on YouTube, you will be able to find us. And then all of these sessions are already there. So you can share it with your friends or your colleagues, or you can also go through them and review these sessions for yourself if you are interested. With no further ado, I would love to start my presentation about dual drainage modeling. As you guys know, you guys stuck with me for the last 4 or 5 sessions. I'm Jason Mahmoudi, the technical specialist and water resource scientist and climate scientist at Smart City Water. The agenda of my presentation today is I'm going to talk about the rainfall runoff in the very beginning, and then we're going to dive under the ground to the sewer system, and then we're going to talk about what dual drainage modeling is. And I'm pretty sure a lot of you guys have already heard or read or know about what dual drainage modeling is, but we want to make sure that if anyone has a bit of we want to make sure that we're both and all of us are on the same page. So when we're talking about rainfall runoff, we're technically focusing on the water cycle. So we have the precipitation, and the precipitation will result either on, so at the very beginning, we're going to have some infiltration if we have some pervious area, and if we don't have any pervious area and it's all impervious area like urban watershed, like roofs and asphalts or concrete or any sort of impervious area, we're going to have runoff right away. And even if we have pervious area, after the soil or the pervious area is saturated, we're going to have runoff flowing over our catchment. So technically, a hydrologic model is a rainfall runoff model, that we have a rainfall, we have a storm event, and then the model, for instance, Visual HIMO, will give us the runoff flowing over, like overland flow on our subcatchments or our watersheds. But when we talk about sewers, we're talking about under the ground. So what exactly is happening under the ground is we do have technically 2 types of sewer designs or sewer system. One is a storm sewer and the other one is a sanitary sewer. We do have another types of sewer, which is combined, but that is technically under the umbrella of storm and sanitary sewers. So the storm sewer, as you can see in this picture, excuse me, the storm sewer is technically designed based on the storm events that we have. In some locations, some places, it is based on 5-year precipitation or 5-year rainfall, 10-year rainfall, 25-year rainfall. So because they're supposed to carry the storm water, when we have the rainfall, when we have runoff, that runoff is considered as a clean water. Debatable, but it is considered as clean water. Why debatable? Because we do have our lovely four-legged kids, I mean dogs, that like there are so many let's say fertilizers that are going to be mixed with the overland flow that would change that clean water to a not clean water, especially environmentally. And some of the time, even the fertilizer that we use for our gardens, that would result in a environmentally hazard for the storm water, because the storm water, the destination of it is an open source water body. So it's gonna go in. We normally carry the storm water and collect them in the storm sewer, and then take them out of the urban area and then dump them in either on a river or on an open source water, which there are some living things in that water. So we may actually increase the amount of phosphorus in that water body, which results in algae. And then that algae is going to be a threat to the lifestyle or to the fishes and the fishery in that water body. But anyway, we consider the stormwater as a clean water. We don't want to treat them so many times, and then we collect them in the stormwater and then take them out of the city. So the destination of the storm sewer is open source water bodies, and then the design of the storm sewer are based on the storm event. Depends on the catchment or the subcatchment that we are at, and then we design them based on that rainfall. On the other hand, we have the sanitary sewer. So the sanitary sewers designs are completely different. They're not supposed to carry any of the stormwater. What they're supposed to carry is the sanitary water, the water from our apartments, our condos, our houses, our homes, our industrial area, commercial area, uh, the water from our sinks, the washroom water, the toilet water. When we flush, that water is going to be collected by the sanitary sewers, and the destination of them are even different. We can't just dump them in on an open source water. So we have to treat that water. So the destination of the sanitary sewer is different. We normally take them to the treatment plants to be treated, and then we can either reuse it or we can dump it into a river. And also the design of them is not based on the storm events. Is that is based on the residential area or the commercial or the industrial area. So there are so many challenges that we have currently, because both sanitary sewer and storm sewer, they both have manholes, and that manhole has a lid, and then that lid has two holes, because mostly in Ontario we're using two pig manhole lids in order to pick the manhole lid easier. And from those two holes, when we have overland runoff flowing over the manhole lid, a lot of the storm water will flow into the manhole. If it is flowing into the storm manhole, it's fine, because that storm water was supposed to be in that storm sewer anyway. But if it is flowing, if that storm event, if that runoff is flowing over the manhole lid of the sanitary system, then the clean water is entering the sanitary pipes, and that is not something that we expected to happen, because the design of the sanitary sewer are not meant to enter or to allow any runoff entering the sanitary sewer. So that's one of them. The other consequence that we have is we are mixing the clean water with the sanitary water. So an excessive amount of water is entering the treatment plant. We need to spend more money to treat that water. That's another consequence. And in some cases, because the design of the sanitary sewer are based on the number of houses and apartments and stuff, we did not see that coming. We did not see the overland flow entering the sanitary system. So the sanitary pipes may get surcharged. And if that happens, we're going to have backup in the sanitary system, and that backup will continue and it will go up. And if any basement of any houses, like the one that you can see here on the right, if the basement is lower than the hydraulic line of the sanitary system, then we're going to have basement flooding. And each basement flooding costs tons of money just to clean, because the water that is going back to the basements are not the clean water, they're the sanitary water. So yeah, that's not pleasant to happen. And also, as I mentioned, for even the storm sewers, it's not always the clean water. So many times, imagine close to a gas station, we are having a lot of pollutants that the overland flow is going to carry them and collect them and take them with themselves to the storm sewers, and then that is going to end up in a river or in an open source water. So those are the challenges, but we don't want to talk about the challenges. So far, we talked about the rainfall runoff. So we have an overland flow on the city, and also we have an overview of what is happening under the ground, which we do have sanitary sewer and storm sewer. So but now, when we connect these two together, because when we have rainfall, when we have overland flow, that overland flow is going to be connected to the underground system. When we connect these two flows together, the flow of overland and the flow of the flow of the sewer system, then this is called dual drainage modeling. So this is a better picture of what dual drainage modeling looks like. So we do have some overland flow. That overland flow will continue, and some of them are going to be captured by the catch basins and by the gutters, and it will come back to storm drain, and then it will be carried out of the city. However, on the other hand, we have houses, we have apartments, we have commercial and industrial area, and then the sanitary water of those areas are going to be connected to the sanitary sewers, and then they're going to the treatment plants. So that was the whole idea of dual drainage modeling, and I want to open VO SWMM. VO SWMM is the swim engine of our is one of our software that we have, because Smart City Water, we do have different software. We have Visual Hymo, and as you guys know, in North America, Hymo is the most recommended software to do any type of hydrologic models, and especially in Ontario, it is recommended by MTO. I'm pretty sure a lot of you guys have either heard about it or already are using Visual Hymo. It is a very powerful software. We have lots of clients across Canada, and we are also starting in US. Also, since we wanted to provide all the need to water scientists and water engineering communities, we came up with a swim engine software that you can also do dual drainage modeling, you can do sanitary design, you can do subcatchments, subdivisions. So it's technically a hydrologic and hydraulic modeling software. If I want to give you a better perspective, it is equivalent to PC Swim. If you've heard about PC Swim before, or Info Swim, or XP Swim, or any other swim engine software. And so it has all the features that any other swim engine software does have. And on top of that, we do have, for instance, we do have dual drainage modeling and manhole INI analysis, which just came out with the new legislation. The new ECA CLI legislation, I'm pretty sure you guys have heard about it, that requires a lot of manhole INI analysis, especially if you have your sanitary manhole on an overland flow routing or a ponding area. So you need to do a manhole INI analysis for that. I'm going to open VO SWMM. So this is the platform, this is the interface of VO SWMM. Both VO SWMM and Visual Hymo works under the same installer, but the engines are different. And so if any of you guys haven't had the chance to use VO SWMM, feel free to email me or reach out to me, and I can create a free trial for you guys because VO SWMM is the most cost-effective software right now in the market. It is less expensive than any other software, and also it has the same features, so it can save you a lot of time, and on top of that, you can save a lot of money as well. So I'm going to open this the practice that I wanted to start, and I'm going to continue this practice the next session, which is going to be the Wednesday after the next Wednesday. So I'm going to open. So I believe that it's going to be August 17th that we have the next session, which I'm going to complete dual drainage modeling in that one. So first of all, if you have VO Swim and if you can't see a schematic or map view, you need to go through the option under the home button. So under the home ribbon, we see the option. I click on the option. I want to see the map view because Visual Althimo and VO Swim are integrated with GIS. You don't have to have the GIS license. You can just take advantage of you seeing a GIS interface. So, and mostly when it comes to dual drainage modeling, when it comes to drainage system, which is sanitary and storm sewers together, when it comes to those, we need to have the shapefile. We technically almost all the time will have the shapefile. If you don't have the shapefile, we have a toolbox that you can actually design your sanitary or storm system, which I'm going to talk about it in a while. So if you can't see the map view, go through options, GIS. Make sure that the GIS is on to GIS, and then select your coordinate system. We have entire world. So if you have a project somewhere in this globe, you can just select whichever coordinate system that you have. I want to choose 17 north, and I will press OK. And I need to restart to make sure that these changes have already been applied. So I will open the new swim project, and I do have the map tab here, or the map interface here. So what I'm gonna do, so this is what you can see in the map view. So you can just scroll down and scroll up. So this is the map view that I have. What I want to do is I want to import my shapefiles, but before that, just make sure on the result or the project manager, you can just go and check out on the properties tab that the unit is in CMS, the cubic meter per second, and also the link offset. I want the link offset to be on elevation. So what I need to do, because I just changed this setting, I want to make sure that I have this project saved. So I'm going through the webinars, the seventh session. I'm going to save it as session 7. So now what I want to do is I want to import my layer, the layer of my manhole, the layer of my sewer conduits, and the layer of my catchments. So I will go through the GIS tools. So by the way, for VO Swim, we came up with micro drainage ribbon. So this is the micro drainage ribbon that it automatically does save a lot of time for you guys. If you have a sag area, it will automatically create and find the sag or the storage unit, and it will create the storage unit for you. Or you can automatically add the node to the link, or you can generate capture curves automatically. This is honestly, this is a fantastic ribbon that VO Swim has. So under the micro drainage, we can see that it's import layer. There is an option called import layer. So what I want to add, first of all, is I want to add my sewer manholes. So I will select the junction in the layer. I will select the junction. So now I want to add the source of it. So I want to add the shapefile. So I will go through the shapefile that I have. So manholes. This is the shapefile that I have. So when I have the shapefile, what I need to do is I need to load the shapefile or the junction map or the junction map junctions. So in each shapefile, you do have some attributes within the shapefile that I need to load them in VO Swim. So when I load them, it automatically fills up. Just make sure that they're connected, or if the you just have to make sure that the attribute that you have for the junctions, for the manholes of yours, is assigned to the correct columns for the layer properties. Like Nash height in my shapefile is called node ID. So make sure all of them are connected. When it's done, just click on import and then overwrite. Here, it will ask you if you are sure, just make sure that the sanitary is assigned to the sanitary, not to anything else, and the storm is assigned to a storm. This import was successful. So this is the first successful import that we had. So if you want to see exactly where they are, we easily can go through the junctions. So the junctions, as you can see, we have the sanitary, but we don't know where they are. I can just easily go and zoom to layer. And as you can see, we can see the greens are the storm manholes and the reds are the sanitary manholes. So these are, the greens are our storm manholes and the reds are our sanitary manholes. So what I need to do is I need to also import our sewer pipes. So in order to do that, again, we're going to go under micro drainage, import layer. I import the layer of our sewers. So the sewers are going to be the conduits. And then I need to import the source of conduits, which are the sewers of ours. And then again, I need to load them. The conduit map conduit. There we go. Just make sure again that the correct information are assigned to the correct layer properties. And again, I will import them. I will overwrite it. So here, what is going to ask you is you just need to make sure that the storm is on storm, and this one is going to be the sanitary. You can, if your shapefile is for overland flow, if you happen to have the overland system, you can just select the overland. Just make sure that they're assigned correctly. This one is my sanitary and the other one is my storm. The import is successful. So, and as you can see, again, the greens are my storm sewers and the reds are my sanitary sewer. And then you can see the direction of the flow as well. And the last thing that I want to add is the catch basin. So for catch basins, what I need to do is, again, under the micro drainage, I need to import the layer. The layer is going to be the catch basins. Excuse me. So I will open my catch basin shapefile. And again, I need to load them. Make sure they're assigned correctly, and then we import them and we overwrite it. So these are my catch basins as well. And then as you can see, the catch basins are here. So for this session, what I'm going to do is I'm going to add a rainfall to the model. Assume that we don't have any overland system, which is a wrong assumption because we do have overland system. That's the whole point of having a drainage system. But I'm going to add a rainfall to the model, and then I'm going to run the system. But before running the system, there is one thing that we need to be careful. VO Swim and VO, Visual Hymo, they both have this fantastic feature that you can automatically Q&A about how you model. So if you go through the error list, it's going to tell you that there are 2 command errors before you even want to run the model. It's going to save a lot of time for you because, as you know, there are so many projects that are so big. So many times we have so much trouble finding where exactly is the issue, but this Q&A will give you a chance. So for instance, if you double click on one of them, it's going to directly take you to that specific node or a specific error, and what's going to tell you is the node does not have a link out. So this node, because the sanitary sewer are flowing this way, this is the end of our sanitary system for this project, and it doesn't have any outfall. So what we need to do is we need to add some outfall to our to the sanitary system of ours. So what we need to do is I need to just add an outfall. I will just drag and drop here. And then as your mouse change to this cross, I just need to click and I'm creating this outfall. So, but what I need to do is I need to make sure that, because I'm just creating a dummy outfall to that, because then I need to make sure that this outfall is a sanitary outfall. So the system, when I click on it on the properties tab, the system type, instead of blank, I need to make sure it's the sanitary. Because if I click on storm by any chance, what we can see here is that the color will change to green. And as you remember, the greens are for a storm, but I need to make sure that the outfall for the sanitary system, the type of it is the sanitary type. So when I click on it, you see that the color has changed to red. So what I need to do is I need to connect this last node of my sanitary system to the outfall. What I need to do is I need to have a conduit. When the mouse changed, just click on this one and then click on that one. So it will automatically connect the last node to the outfall of mine. Again, make sure that this conduit is also a sanitary conduit, and the shape of it is just a dummy one. So I will go through the pipe shape. I will come down. It says it's a dummy. So the software automatically creates a dummy one. And I need to make sure that the ground elevation, because I don't want the software to think that it is coming over the ground or under the ground. What I need to make sure is I need to make sure that the inlet elevation of so they're all in the same locate. They're all in the same profile. So what I am going to do is I'm going to select. So that hasn't changed yet. Oh, there we go. So, and also if you see that the type of the conduit hasn't changed or the color hasn't changed, if you just zoom in and zoom out, it's going to automatically update it. So don't freak out. It's just going to happen. So I will select my last node. So the invert elevation of my last node is going to be the same as the slope of this conduit, this dummy conduit that I created. So both of them are going to be the same. So the inlet elevation and the outlet elevation of my dummy conduit should be the same, because I want it to be in the same elevation of the last node, because it's just a dummy one. As well as the outfall conduit, I want the outfall inlet elevation. I want it to be the same as the last node of mine. So this is going to be all the inlet elevation of this part is going to be the same because it's a dummy part. Now, as you saw, one of the errors in the error list has been removed automatically, but there is another one. I will double click on it. It's going to take me to the other part. This part is we have the last part of our storm sewers. And as you saw, this is the flow for the storm event or for the storm sewers. And this is the last part of it, and there is no outfall associated with that one. So I need to do the same thing that I did for sanitary system for the storm system. What I need to do is I need to add an outfall. I will just add this outfall. I will connect this conduit from the latest node of my storm system to this outfall. And what I need to do is I need to make sure that this is a dummy outfall. So in order to do that, I need the inlet elevation of the last node of my storm system to be the same as this dummy conduit. So the system blank, make sure it is on storm. So if I go scroll down, it is green now. So this is storm. The shape of it is just a dummy. And then I copy this, the inlet elevation for the last node of my storm system. I want it to be the same as the inlet and the outlet elevation of this conduit, the dummy conduit. And I want to make sure that the outfall of mine is in storm and the inlet elevation is also the same as this dummy conduit. So all the errors are gone. So now all I need to do is I need to add my storm event. In order to add your storm event, you easily can go, it's the same as Visual Authimo. You can go to resource library. So you either can use one of the already embedded or already built in storms that we have. We have the Hazel, for instance, from TRCA. So we try to make it as simple and as easy as possible and save a lot of time. So, or if you have your own storm event, you easily can just select that one and go from there. So I happen to have a storm event. I want to read in a storm event. So I just click on read in here in the new design storm. I browse it. So make sure if you have a storm file, then perfect. And if you don't, just make sure you're selecting the CSV files. My CSV file is the rainfall, and then I select it and it will show up here. So this is the rainfall that I have. And if you don't want to have your library messed up, what you can do is you can create a different one here. For instance, if I can just go through this top group option, I can create a new one. I'm going to call it session 7. And then I'm going to read in, same location, rainfall data. And now it is created under this one. So rainfall data session 7. The unit is on metric. And then now you have this here. You can also save this to be part of your saved library. So you can use this later on as well. I want to add this rainfall to my model. And then I just click on add to model. I'll select OK. And then I can come back. It will ask me if I want to save this in my library. Yes, let's say that we want to save it in our library. So in this session, we saw that we added a storm event. We added our shapefile of our conduits, manholes, as well as the catch basins. So also you can see that my rainfall is added to the model as well. So what we can do is we can just run the simulation now. But first of all, I want to make sure that the time steps of my run is actually properly. For instance, I want to have my reporting to be 5 minutes instead of 15 minutes, or I want to have, let's say, I don't want to have any control step. I want the routing to be instead of 30 seconds, you can make it 60 seconds or whatsoever. But I want to have it 30 seconds. Just make sure that the reporting, you want the software to report the runoff each 5 minutes. So the routing cannot be more longer than that. So the routing always should be less than the reporting. So this is what I want to have. And then I will just click OK. I can go to running the model. And then just make sure that the timings are also okay. I have the end analysis. I want it to be 12 hours, let's say. And then the other things, the end SWMM, I want it to be the first day of the month. And all are set here. So I can just run the model. The batch has run successfully. But again, this is a rainfall with no overland system. And also we have the drainage system. So what we need to do is we need to model our overland flow and then connect our overland flow to our drainage system. And then at the end, it will tell us, the software can tell us which parts are going to be flooded, or how is the condition of our sewer or our drainage system is, and if we are going to have any overland flow when the overland flow is connected to the drainage system. And using the same procedure at the end of the day, we also can do a manhole INI analysis, which is here, but since we haven't done any flood mapping before or any flooding before, this icon is going to be activated when we happen to have the flood mapping at the end. So you can select the manhole INI analysis or manhole inflow analysis, and then at the end, what it's going to tell you, it is going to locate which sanitary manholes are submerged. So this is exactly the map that you need for the new ECA-CLI legislation of Ontario, and VO SWMM is the only software that has the manhole INI analysis. For this session, I'm gonna stop it here because if I want to continue, then they're all connected to each other. So I will continue from here 2 weeks from now on August 17th. So make sure that I'm going to send you guys the link for that meeting as well, probably 2 or 3 days prior to the meeting. That was the session. If you happen to have any question for this session, just feel free to ask in the chat option that we have. And if not, I'm going to let you guys go. Enjoy your meal, and we'll catch up on August 17th. I'm just gonna wait for maybe 2-3 minutes or less than that to see if anyone has any question. And again, if you guys want to use VO SWMM, just let me know. Email me. I'm going to create a free trial for you guys so you can try out to see how it is, if you like the software, if you like the interface. And then especially for our current client for Visual Authimo, if you are using Visual Authimo, we always have promotion for VO SWMM because you can use VO SWMM and VO under the same installer, and they're compatible with each other as well. So if you want to use that one, just let me know. I assume there is no question. I'll let you guys go. Thank you so very much for staying with us and for participating in a 7th session of Smart City Water's webinar. We talked about the first half of dual drainage modeling, and on August 17th, we're going to continue and finish this project that we were talking about, and we will add the overland system, which a lot of time the overland system is a pain to model, but we'll do it and we'll see how easy it is to do it with VO SWMM. Thank you so very much for staying with us, and we'll see each other on August 17th. Have a great day.